Let's recreate a classic game, Flappy Bird, using only JavaScript. We'll even code some weird googly eyes because why not? Let's start by changing the background to a nice sky blue color. Okay, let's run our code by pressing the play button. Let's create some variables to keep track of the important data in our game. We'll make a variable for the bird and hard code the amount of gravity and lift we want in the game. The velocity variable will keep track of the bird's velocity at any given moment. We'll also create some empty arrays for our pipes and clouds and set the score to 0 and game over to false. I'll be explaining all of these variables as we code the project, so don't worry about them too much at this stage. We'll give our bird a starting point in the game by creating a vector, in other words, an X and Y coordinate, at position 50 horizontally and halfway down the canvas vertically. Let's start drawing our bird now as a yellow ellipse. I want our bird to look cute, so I'm going to give it an orange triangle beak. I work the coordinates of the triangle by drawing the bird on graph paper and working out what each point should be. And I'm also going to draw the bird's eye too. We'll set the stroke to 200 to make it lighter, and then draw the eye as a white ellipse. Let's also give our bird a black pupil inside its eye. But I'll make the pupil dynamically move up and down based on the bird's velocity, but constrained so that it only moves between 5 and -5 pixels inside the eye at any one time. This will add to the visual appeal of our little hero. Let's work on making our bird fly now. We'll start by adding the current velocity variable to the bird's Y position. We then need to work out what velocity should look like in the next draw cycle. We'll add gravity and also multiply by 0.9 to simulate some wind resistance. Because we haven't implemented any user interaction, this means our poor little birdie will quickly fall off the screen for now. Don't worry, we'll fix this soon. Let's help our little friend out now by implementing the key pressed method. When we press the spacebar, we'll add some lift to the velocity, making our little birdie move upwards against gravity. Let's see if that works. Let's start adding the pipes, which will be the obstacles in our game. For now, we'll just create the pipe class with an empty constructor, as well as the show and update methods. Now that we have our dummy pipe class, let's start wiring everything up. We'll head back to our setup function to add the first pipe to the pipes array. Then in the draw function, we need to loop through the pipes array and call each pipe's show and update methods. Because we will later remove pipes when they go off stage on the left-hand side of the canvas, we're iterating through the array backwards so we can avoid any errors if a pipe is removed during the loop. We also want to add a new pipe every 100 frames. That way there'll be a never-ending supply of obstacles for our bird. Let's start working on implementing the pipe class. First, we need to pick the Y position where the top pipe ends. This will be our this.top variable. We also need a this.bottom variable to represent where the very top of the bottom pipe begins. We use the random function to pick these two Y values, ensuring we have at least a gap of between 125 to 200 pixels in between the pipes so our bird has a chance of flying through. We'll set the X position of each pipe object to initially be the very right of the screen, in other words, the edge of the canvas, or its width value, and the pipe's width will set to 45 pixels. For the pipe speed, we'll dynamically increase the speed based on the global frame count, with a minimum of 2 pixels every time we redraw the screen. This means our game's level of difficulty will always increase. We can now fill out the pipe's show method. We set the stroke color to lime green and the fill color to green. We'll then draw 2 rectangles, the top and the bottom pipe. At the end, we'll call the no-stroke function to clear out the lime green stroke we set. Before we can see our pipes, we need to write the update method, where we'll update the X position based on the pipe speed. We can now take a look at our creations. Okay, this is working well, except I can illegally fly through the pipes. Let's fix that by creating a new pipe class method called hits. This method will take an object, i.e., our bird, and test whether its X and Y position intersects with either the top part of the pipe or the bottom part. If so, we'll return true, otherwise we'll return false. Now we'll call the hits method inside the global draw function when we're drawing each pipe. If a bird hits a pipe, we'll set game over to true. Before we test if that has worked, let's quickly add some logic to display a big game over message if the game over variable is set to true. Great. Let's now add some additional features to add an extra layer of polish. First, I want to display the player's score. The score will be calculated as the number of obstacles the player has successfully navigated. I've added a new function called showScore and called it inside the draw function in 2 places to ensure it's visible during the game and on the game over screen. The showScore function simply displays the score in the top left of the screen. To keep score, we need a way to know if a pipe has disappeared off the left-hand side of the screen. We'll add a method to the pipe class called offScreen, where we'll test if a pipe's x-coordinate has gone all the way off the screen. Now back in the global draw function, we can test each pipe to see if it has gone off screen. If it has, we'll remove it, or splice it, from the pipes array and increment our score. Amazing, that's working really well. The final thing I want to do to make our game look incredible is add some clouds in the background. These clouds will move at a slower speed than the pipes, giving us a nice parallax effect. Let's create a new cloud class. The constructor will take an optional argument called offScreen, which will default to false. If the cloud is starting off screen, we'll set its x-coordinate to be the width of the screen plus 100 pixels. Otherwise, we'll just pick a random x-coordinate on our canvas. We'll set the y position of our cloud to be somewhere in the top third of the screen and set its size to be a random value between 50 and 100. We'll also pick a random amount of transparency between 50 and 200 to ensure that not all of our clouds look the same. Let's write the show method now for clouds. We'll call noStroke to ensure there is no outline. We'll be sure to pass our selected transparency value to the fill method. Then we'll draw the cloud as a simple ellipse. Finally, we'll implement the update method, moving our clouds 1 pixel to the left per draw loop, and an off-screen method with similar logic to the pipe class. Almost done. Let's go back up to our setup function and create 5 clouds. We don't set the off-screen parameter to true because we want these clouds to be immediately visible. Finally, we'll loop through our clouds in the draw function and call the show and update function on each one. If a cloud is moved off screen, we'll remove it from our clouds array and add a new cloud in its place. For this new cloud, we'll set off screen to true so that it starts its journey all the way on the right-hand side of the screen. Our project is now finished. If you want to learn to code in bite-sized steps, like this video and subscribe. Until next time, happy coding.